Welcome to our episode on explaining scientific concepts using academic English. Dr. Carter, can you start by outlining why formal language is so important for scientists and students alike?
Absolutely. Academic English allows us to communicate complex ideas with precision and objectivity. For example, using passive voices such as experiments were conducted removes subjectivity and emphasizes the process or result, which is key in scientific writing and presentations.
That's a great point. So, how does this clarity benefit researchers, especially when discussing topics with international audiences?
Clarity reduces misunderstandings. When technical terms are clearly defined and logical connectors are used, such as subsequently or however, it ensures all listeners, regardless of background, follow the explanation. This is essential in global collaborations.
Let's talk about the introduction phase. How should a speaker formally introduce a scientific concept, say to a classroom or conference audience?
A formal introduction often includes a concise definition and the relevance of the topic. For instance, one might begin, "Today, we will examine photosynthesis, the process by which green plants convert light energy into chemical energy." This sets clear expectations and establishes context.
It sounds like context is crucial. What language features can help establish that context effectively?
Phrases like, "It is important to note that," or "according to recent studies," immediately anchor the discussion in its scientific significance. Additionally, referencing current research or applications grounds the topic in real-world importance.
Moving forward, let's consider definitions. How can one define key scientific terms so the audience clearly understands?
Precise definitions often use formal structures. For example, photosynthesis is a process by which plants, algae, and some bacteria convert carbon dioxide and water into glucose and oxygen, utilizing sunlight. The passive voice, as seen here, emphasizes the process rather than the actor.
Can you explain why passive voice is so commonly used in these definitions?
Certainly. Passive voice avoids focusing on the scientist and instead highlights the phenomena. In scientific communication, objectivity is valued, so we say the experiment was performed rather than we performed the experiment.
After defining terms, explaining processes often involves multiple steps. What strategies help ensure logical flow when describing, say, the stages of photosynthesis?
Sequencing is critical, using formal connectors like first, next, subsequently, and finally guides listeners through each stage. For example, first, light is absorbed by chlorophyll. Next, energy is transferred to electrons. The structure mirrors step-by-step instructions, enhancing comprehension.
Would you recommend summarizing at the end of such explanations?
Absolutely. Concluding with a summary sentence like, "In summary, photosynthesis transforms light energy into a usable chemical form, reinforces the overall process, and aids retention."
Sometimes abstract concepts need concrete examples. How can analogies and examples help make scientific topics more accessible?
Analogies bridge the gap between the unknown and the familiar. For example, describing chlorophyll as a solar panel that captures sunlight helps non-experts visualize its function. Real-world examples, such as how photosynthesis supports global food chains, also contextualize the science.
Are there risks in oversimplifying with analogies?
Indeed, oversimplification can distort meaning. The key is to clarify the limits of an analogy, stating, "While chlorophyll functions like a solar panel, the underlying chemical processes are far more complex."
Let's focus on vocabulary. What are some essential academic expressions and technical terms for scientific explanations?
Terms like carbon dioxide, conversion, glucose, and cellular respiration are foundational in biology. Academic verbs such as demonstrate, indicate, and suggest convey evidence and objectivity. Phrases like, "The data suggests that," communicate findings formally and precisely.
How can learners expand their academic vocabulary in science?
Reading research articles and noting recurring terminology is effective. Creating vocabulary lists and practicing usage in sentences, such as research indicates that builds fluency over time.
Suppose a speaker wants to support their explanation with research. How should one integrate data or studies in a formal presentation?
Citing studies strengthens credibility. For example, according to a 2021 study in Nature, increased light intensity correlates with higher rates of photosynthesis. Presenting statistics, such as photosynthetic efficiency can reach up to 8% in some crops, adds specificity and authority.
Are there best practices for referencing sources verbally?
Yes. Clearly mention the source and year. A recent article in Science, published in 2023, found that so listeners can evaluate the evidence and, if interested, locate the study themselves.
Complex scientific concepts often have exceptions or limitations. How can a presenter address these effectively in academic English?
Acknowledge counterpoints with phrases like, however, it is important to note that, or, while this is generally true, exceptions exist. For example, although most plants perform photosynthesis, some parasitic species obtain energy differently. This demonstrates critical thinking and thorough understanding.
Does this approach enhance the persuasiveness of the explanation?
Definitely. Addressing complexities shows intellectual honesty and builds trust. It signals to the audience that the speaker has considered multiple perspectives and is presenting a balanced view.
Let's shift to the interactive component. What activities help students practice explaining scientific ideas in formal English?
One effective method is to choose a simple process like water boiling and explain it in 3 to 5 formal sentences. Learners should incorporate connectors like furthermore or consequently and use academic verbs such as illustrate or demonstrate.
What about practicing passive voice structures?
Absolutely. Students can rewrite active sentences. For example, change plants absorb sunlight to sunlight is absorbed by plants. This exercise reinforces objectivity and formality.
To conclude, could you summarize the essential steps for explaining a scientific concept in clear academic English?
Certainly. Begin with a clear introduction and definition, sequence processes logically using connectors, integrate examples and data, address limitations, and employ precise academic language. Practicing these strategies enhances both clarity and credibility.
Thank you, Dr. Carter. For our listeners, remember, mastering formal scientific English is a skill that opens doors in research, education, and professional communication.
Thank you for having me. With regular practice, anyone can develop the confidence to explain complex ideas clearly and formally in academic contexts.